So welcome everyone once again. So today we are talking about the trigonometric ratios of 30 degrees, 60 and 45. So before we proceed, you get your calculator and press cos 60. If you press cos 60 on your calculator, it will give you a 0.5. And if you press sine 60, it will give you 0.8666, which is equivalent to root 3 out of 2, which is equal to root 3 out of 2. If you place sine 30 is a half, and cos 30 is root 3 over 2. The same applies if you place tan 60. Tan 60 is going to give you something like 1.73 like that, which is root 3. And when you press tan 30, it is going to give you 1 over root 3, the equivalence of 1 over root 3. So specifically we are going to dive into that, and we see where it comes from. We are starting with 30 and 60. So here we consider an equilateral like previously when we talked about the general angle. We are dealing with the trigonometric ratios, and we said trigonometry, it is the relationship between, it is the branch of mathematics that talks about the relationship between the lines of a triangle and the angle. So specifically, we are dealing with an equilateral triangle because we know if all sides of a triangle are equal, it means that even the angles inside the triangle are always equal, and they are 60. They must be 60. Since they are always 3 and they are equal and they must add up to 180, so they are 60. So we consider an equilateral triangle. I can draw one here. Maybe let me try to draw it like this. So if this is my equilateral triangle, so all sides are equal, so we can call n of the sides. N of the sides, we know this is angle 60. I can call this triangle A, B, ABC. So it means that this angle is also 60. But like I told you in the previous videos that we are dealing with, we are using the Pythagoras theorem. Pythagoras theorem. And Pythagoras theorem only works when we have a right-angled triangle. So if I draw a bisection, a line perpendicular such that it makes an angle of 90, this line, you realize that it cuts our equilateral triangle into two equal parts. So it means even the angle here is going to be split into two equal parts. So it means this is 30 and this is 30. So now we can do our mathematics Pythagoras theorem. So what do we need? We need to find this length. What is the equivalence of this length? So it means that if this length is, say, R, I'm going to call it R. It means that this is also R. So it means that this is R over 2 and this is R over 2. So it means it has been cut into two equal parts. So I can name this point P. So from here, this is angle 90. So I can use any of the two triangles to get the sine of that and cosine of that. But before we go ahead, I want to find length AP. Length AP. So we say from Pythagoras theorem. Pythagoras theorem tells me that if I have AP squared, this squared plus that squared is equal to that squared. AP squared plus PC squared is always equal to AC squared, i.e. my AP squared is AP squared, it's the one I want, then plus r squared over 4. This is equal to r squared. So my AP squared is equal to r squared minus r squared over 4. This gives me 3r squared over 4. Because this is 4 over 4, 3r squared over 4. My AP. So my AP, length AP, is given by the square root of this. I'll remain with root 3r over 2. So the length here is root 3r. The r is outside. Have to keep that in mind. It is root 3r over 2. So then I can say, using triangle, let's say, let me stick with my triangle APC. APC. What is the cosine of 60? The cosine of 60, if this is the angle that we are considering, this is the adjacent. The adjacent and the hypotenuse are the ones that give us the angle that is. Okay, the angle is always adjacent to this line. We call it the adjacent. This is the adjacent, so it is r over 2 out of r. So it is r over 2 out of, and this is going to give you 1 over 2. So that's why you always find that cos 60 is a half. So in some books they always use 1 here, 1 here, and a half. So I've just used r to show you that any length you use, so long as you obey the rules of an equilateral triangle, you shall still come up to this. Even if I used 5 here, 5 here, this would be 2.5, 2.5. You get the length there, get the ratio of the yoke side. It is going to be a half. So whichever course you take, you arrive to the same thing. What is sine 60? It is the opposite of adjacent, so it is root 3r over 2 divided by r. This is root 3 over 2. What is tan of 60? Tan of 60 is opposite of adjacent, so it is root 3 over 2 over 2r divided by r over 2. This is root 3. So what is sine 30? Sine 30. Now we are considering this triangle, the same triangle, but we are considering this angle. So if this is the angle, so the adjacent now changes to root 3 over 2r. So, and the opposite becomes this. So it is r over 2, but the hypotenuse doesn't change. The same applies for cos 30. If this is the angle, this is the adjacent, root 3 over 2r divided by r, which is root 3 over 2. Then tan 30 is opposite r over 2 divided by this. So it is opposite r over 2 divided by root 3 over 2r. This gives us 1 over root 3. So you see that there is a relationship between the 6 of them. You realize that cos 60 is always equal to sine 30 and is always equal to a half. And the same applies for cos 30 is always equal to sine 60. These are angles, and is always equal to root 3 over 2. And tan 60 is always equal to 1 over tan 30 and is equal to root 3. Like that. So basically, those are the known trigonometric ratios of 30, 60, 30 and 60. So now we can talk about the ratios of 45. It is the same procedure that we follow, but now this time around we shall deal with an isosceles right-angled triangle. What does that mean? So we have finished talking about the ratios of 30 and 60, and we have established the relationship between the two. So now we are talking about the 45. If we talk about 45 degrees, what comes into your mind? Remember, we had for 30 and 60, we had a triangle like this where we had 30, we had 60, and this is 90. And we know that the angles inside this triangle must add up to 180. 90 plus 60 plus 30, it is 180. So how do we create a 45? It means that we shall have a right-angled triangle. If this is my right-angled triangle like this, if this is 90, and I want one of the angles to be 45, this automatically tells me that this is 45, because they must add up to 180 if this is my triangle ABC. So that is the first step. We have established the triangle. What do you see on this triangle? Do you realize that the triangle is isosceles? The two opposite sides are equal. Since the angles here are equal, then these sides must be equal. That is very important. So it means that if this side is R, also this one is R. How do we get this? Using what? Pythagoras theorem. Using Pythagoras theorem, R squared plus R squared is equal to length BC squared. So this is 2R squared, which is equal to BC. So our length BC is equal to root 2R. So we can simply put it here, root 2R. Then we establish our trigonometric ratios. Sine 45. What is sine 45? Sine 45 R over this. So it is R over root 2R, which is 1 over root 2. Or you can, this is the same as root 2 over 2. The same. Then cos 45 is equal to the same thing, adjacent over hypotenuse. R over root 2, R, which is 1 over root 2, which is equal to root 2 over 2. So if you don't know how I've got, this is 2. If you don't know how I've got this, multiply here root 2 and here root 2. Root 2 times root 2 is 2. Simple. So now, what about the tan 45? Tan 45 is always this over this. So it is R over R, which is 1. So you realize that. So we realize that what? That sine 45 is always equal to cosine 45 degrees. That is very important, and this is always equal to root 2 over 2. You can confirm that on your calculator. It is very correct. So that is specifically what we can talk about. That, so it means that if you're told, I can give an example. Simplify this tan 60 minus I sin 30 over cos 30 minus plus I tan 45. So you don't need to hustle with this. You don't need to hustle with that. Just know the equivalence of tan 60. It is root 3, like we have talked about. Just replace, rationalize, and simplify your answer. As simple as that. So that makes it the end of today's lesson. Meet you in the next video, where we shall be talking about the Pythagoras theorem and the relationship between this trigonometric ratio. We have a relationship between sine and cos, and we are going to also talk about other trigonometric ratios. Did you know that you know that we have a trigonometric ratio of 1 over sine theta and 1 over cos theta and 1 over tan theta. So this is always called cosec theta, and this is sec theta, and this is cot theta. So in your O level, you have been used to this, this, and this. So at your advanced level now, we are introducing other trigonometric ratios. 1 over sine is sec theta. 1 over cos, no. 1 over cos sec theta. 1 over tan cot theta. So in the next video or in the next lesson, we are going to talk about these, the relationship between them and how we can use them to solve very many equations. So specifically, that is what we are going to be talking about. I want to wish you a wonderful time and thanks for watching. Please share these videos to your fellow students. Share as far as you can share. Thank you so much.